All right, so now let's have a look at the graph of exponentials. This is basically the general form. So when your base value is greater than 1. Okay, so first of all, so let's have a look at the case when your base is greater than 1 and the power is a positive power. Could be x, could be 2x, could be x plus 1 and so on. Could be any value. But the main point is that the power is a positive value. So your graph will be increasing. So it's going to increase going up. And what happens if your base is raised to a negative power? So the graph will be going down. So basically it's decreasing. And in terms of the domain and range, so what happens is that the domain is going to be from negative infinity to infinity, and the range will be from 0 to infinity, but 0 is not included because here, so if you have, for example, y equal a to the power of x, so what happens is that no matter what is going to be, so if I have some number raised to the power of x, so the main point is that it will never become negative. So even a to the power of 0 is going to be 1. So it will never become a negative value, which is why, so we have an asymptote. So it's written over here. So the asymptote is y x-axis at y equal 0. So that's just an asymptote right here. So the range is going to be from 0 until infinity. So the graph has y-intercept at 0, 1, because when x is equal 0, so I'm going to have y is going to equal 1. So the intercept right here, so this is going to be a value of 1. So as I mentioned just now, when a is greater than 1, so what happens is that when we have power is positive, the graph increases. And when for a greater than 1, when the power is negative, so the graph will be decreasing. So what happened here? Okay, so actually I provide this space so that I can explain to you about this term, about the statement here. So it says that the greater the base, the faster graph rises from left to right. Okay, let's suppose I have two functions. So I have f of x equal 2 to the power of x, and the other one is f of x equal 3 to the power of x. So how will they differ? So in terms of the intercept will be the same, because when x is equal 0, y is going to equal 2 to the power of 0, it's going to equal 1. And same goes for this function. When x is equal 0, so y is going to equal 3 to the power of 0, it is still going to equal 1. But of course, the shape will be different. So let's suppose this is going to be my axis. And remember, this over here, this is going to be our asymptote. So it's going to be approaching, but it's not going to intersect the line. So this is going to be my x-axis. This is going to be my f of x-axis. So first I'm going to sketch the 2 to the power of x. So let's suppose the 2 to the power of x looks like this. So this is going to be a value of 1. So this is going to be the graph of f of x equal 2 to the power of x. Okay, how are they going to be different? So the intercept is going to be at the same point, but when this number, because 3 is greater than 2, so it's going to increase higher than 2 to the power of x. So what I mean by that is, so the graph is going to look like this. Okay, so what happened is that my graph for 2 is going to be higher than the graph for 3 to the power of x is going to be higher than the graph for 2 to the power of x is going to rise higher than that. That will be the difference, okay? By the intercept, it will still be the same. Okay, so I'm going to show you how to sketch this following exponential functions. So we have all sort of scenarios right here, but basically the idea will be pretty much the same. So question 1. So I'm going to start with a, for which I have f of x is equal 3 to the power of x. So if you have a look at this function, according to what we have discussed before, so 3, the value is greater than 1, and here I have a positive power, so I know that my graph will be increasing, it will be going up. And here, in terms of the intercept, so when x is equal 0, y is going to equal 3 to the power of 0, so it's going to equal 1. So my intercept point is going to be at 0, 1. So if I were to sketch, the graph is going to look like this. So I'm going to have an asymptote at 0. So my graph is going to look like this, and this is going to be a value of 1. So let me highlight the asymptote so that we'll know this is actually an asymptote. So that's how the graph looks like. That will be for A. that is like the most basic function for exponential. And if you sketch exponential e to the x, that's going to be pretty much the same, but it's going to be lower because this is a value of 3 and e is a value of 2.7. And for b, I have f of x equal to exponential of negative x. Okay, so this is going to be pretty much the same idea. So what happened is that here my a value, my base value is equal e, and we know that e is 2.7, that's greater than 1. And in terms of the power is going to be negative, so we know that the graph is supposed to be decreasing. And in terms of the the intercept, so it's pretty much the same idea. So when x is equal 0, I'm going to have y is going to equal 2 exponential of negative 0. So that is going to equal 2. So therefore, what happened is that now my intercept is going to be no longer at 1, but my intercept point is going to be at 2. Okay, this is going to be my sketching. So the graph is supposed to go down, and the intercept point is going to be at 2. So you just take somewhere over here, and the asymptote is still going to be the same, okay? And this value right here, this is going to be a value of 2. So that is going to be a graph of 2 exponential of negative x. So it doesn't have to be exact, it's just like I wanted to see roughly how the graph looks like. It doesn't have to be like super exact. This is a sketching, that's why it's called as a sketching. Okay, so for c, what else do we have? F of x equal exponential of x plus 2. X plus 2. Okay, so if I were to apply the property, remember the exponential property, so this can actually be separated to exponential of x multiplied by exponential of 2. And what is exponential of 2? Exponential of 2 is practically a constant. So you can use your calculator for this. I don't have my calculator with me, but I think the exponential of 2 is going to be 7 point something. So try it for yourself. So it's simply going to be a number. So do not worry about that. It's simply going to be some number. Okay, so now what happened is that now my e, so we know that e is going to be greater than 1, and the power here is going to be a positive power, which is to the power of x. Now let's find the intercept. So here when x is equal 0, so y is going to equal exponential of 0 plus 2, which is going to be exponential of 2. So one is catch. So my graph is supposed to be increasing. So the intercept point is going to be at exponential of 2. There goes my exponential of 2. So that's how the graph looks like. All right. And the last one, I think, the last one is going to be d. So d is going to equal 2 exponential of negative x plus 2. To the power of negative x plus 2. Okay, so this one is going to be slightly more complicated. So remember when we discussed, I think it was 2.5, so transformation of functions. So I will implement that idea. So first of all, what I'm going to do is I'm going to sketch g of x equal to exponential of negative x. And based on this idea, what happened is that here I have a negative power because it's going to be negative of x, and my intercept is going to be at 2 to the power of 0, that is going to be 1. So my graph is going to look like this. Okay, and this is going to be a value of 1. So now what I'm going to do is I'm going to translate this. So I'm going to have g of x plus 2, so which is now going to be 2 to the power of negative x plus 2. And we know that when we add plus 2, what happened is that the graph is going to be increasing 2 units upwards. So please recall what we have learned in 2.5, okay, translating the function. So I have f of x plus 2 or g of x plus 2, so meaning the graph is going to go 2 units upwards. So what happened is that previously, so we have asymptote at y equal 0. And when we translate, even the asymptote is going to translate as well. So that is why what happened is that, okay, from y equals 0, So now my new asymptote is going to be at y equal 2. So this is going to be my asymptote. Okay, so it goes up 2 units because we have plus 2. If we have minus 2, then it goes down 2 units. Okay, but the graph is still going to be the same. Okay, but now what happened is that the intercept as well. So previously the intercept is going to be at 1. So now when I add up 2 points, so my intercept value is going to be at 3. So therefore when I sketch, it's going to look like this. And this is going to be a value of 3. That's it. Okay, so that is going to be a graph of 2 to the power of negative x plus 2. So basically I used the idea that we have used before for the case of transformation. Okay, the last one, question number 2. So we are given a function f of x equal exponential of x. First, we're going to find the inverse. And then we're going to sketch the inverse and the function f of x equal exponential of x both on the same axis. So this, we will combine the idea of exponential, what we discussed in this topic, and the previous topic in 2.6. Okay, now let's start with finding the inverse. Okay, for a, first I'm going to let y is equal exponential of x. So remember the concept of log and exponential. So now what happened is that if I want to get x, I have to get rid of the exponential there. So how do we get rid of exponential? So the inverse of exponential will be log. The idea is going to be something like this. So if I have log of exponential of x, these two will cancel each other, so that is going to equal x. Or if I were to have exponential of log of x, again, these two is going to cancel each other, it is going to become x as well. So mainly log and exponential, they are the inverse of each other because this ln is actually log to the base of e. If you notice, I don't pronounce this as ln. So actually ln doesn't exist. Only we Malaysians pronounce it as ln. But I have once been scolded by a German lecturer when I was in New Zealand because I pronounced it as log. He told me that there's no such thing as ln. Everything is actually log, and ln is actually log to the base of e. So that is why when I say log, and I'm actually referring to this ln right here. Okay, so be mindful in that, the fact that log and the exponential, they are the inverse of each other. So that is why, so when I wanted to get rid of the exponential, I'm going to log both sides of the equation. So log of y, so no, I'm going to use log of base 10. I have to use log of base e to cancel the e. So I'm going to have log of y is going to equal log of exponential to the x. So now these two are going to cancel each other. So I have x is going to equal log of y, or basically, so what we're looking for, f inverse of x is actually going to equal log of x. So that is going to be the inverse. Okay, so that is for A. For B now, we are going to do the sketching. Okay, so this is going to be my axis. We know that when we want to sketch the inverse, so what we need is going to be a straight line. No, that's not very straight. Okay, so this is going to be a line of y equal x. Okay, so I'm going to first sketch this function right here, the f of x, so which is exponential of x. So my graph is supposed to be increasing, it's supposed to be going up, and my intercept value is going to be at 1. For example, let's say I have a 1 right there. So this is how the graph is going to look like. Okay, so that's ideally how my graph is going to look like. Okay, so this is going to be my graph of f of x. And we know that if I wanted to sketch the graph of f inverse, all I have to do is reflect the f of x on the line of y equal x. I'm going to pretend there's a mirror at y equal x, and I'm going to use that to sketch the inverse. So therefore, the inverse is going to look like this. So the first part, so if this is 1, this is going to be 1 as well here because they are symmetric. So the first part is going to look like this, and the second part is going to look like this. So that is how the graph is going to look like. Okay, so in terms of the asymptote, for the case of f of x, so I have asymptote at y equal 0. So this is my asymptote, where the asymptote is. Okay, but what happened for inverse is that it will be the opposite as well. When it comes to cross the inverse, I will also have an asymptote but my asymptote is going to be at x equal 0. So previously it's on x-axis, but for the case of inverse, my asymptote is going to be the opposite, which is going to be on the x-axis. That is why. So if you notice this line right here, so I go close towards the line, but I do not cross the line because there will be an asymptote on the y-axis. So that is going to be for B, and let's label it right here. So this is going to be the graph of f inverse of x, which is going to be a function of log of x. Okay, so I'll give you the exercise later for you to try, but that is going to be